What was going on?
Are you okay? Yeah, I don't know if I can believe does it, right? God.
You're my rock.
Because Jack is being he's like, well, right now no one has it because my dad didn't want to go that. And I'm like,
Cannot stay with Donahue's. I'm not allowing you guys.
I can sleep on the floor though, right?
Can we sleep outside your door? You can serve us a pillow?
Yeah, this is on this bottom.
As long as you give us a water park wristband, I don't care where I sleep.
Garrett.
Have a good day, everyone.
Garrett. Should we just go and then anyway, once we're there they can't tell us no.
Oh yes, they can.
Yeah, they can.
You mean the wilderness can't tell you no?
Yeah, I think they Jack.
They're like, oh, where are you staying?
Someone will have to take a sit. Just be like,
Yeah.
our mom dropped the stuff. We can
The Donahues.
Otherwise we have to sleep on the side of the road.
My mom said she's not coming back till Sunday.
Oh man. Because I suppose Isaac's gonna be there, right? Yeah. Like, we got cheap hotel. Like we had like a group rate that was like a $130 a night. It's a pretty good deal.
Seriously?
Yeah.
I would have stayed there for a whole week if you had that.
Mr. Donahue was trying to be cheap, and he's like, "We should just go for one night." I was like, "It's $130."
Does Mackerel have your class ever today?
No, I don't teach until next semester.
It's his birthday today. I was gonna
Oh,
write happy
really?
birthday now.
Oh.
Yeah.
If he had a class.
Birthdays make things. Yeah.
Of course he would.
Okay, so we're starting with our warm-up is fractions.
Oh.
And I'm trying to ask you guys if you do this out of calculator, see what you guys remember about fractions and the rules with fractions without a calculator. So take a few minutes to try those and kind of see what you guys remember. Now, I'm not taking a calculator away from you this chapter, but if you don't know how to do these by hand, we have to talk about them because we have to do them now with algebra, and your calculator doesn't do that for you. That's weird, because like John and like those guys are still on my attendance. Mark an absent.
Subjective.
Well, I said, I know you told a lot of people, so like, just let me know if I'm still able to stay with you. And he's like, well, I don't know right now because we can't get the room yet. So, and he's like, I didn't ask him about it.
If you honestly though don't have enough water park passes, it's possible. I mean, like we don't necessarily need both our, you know, because I think you get 4 per room. Like if that's the issue, like, but you need some place to stay.
Yeah, right now.
Wait.
Sleeping on the lawn chair in the.
If you have extra water passes, we'll take them.
Don't
I
go in
don't
the
know.
bed,
Why?
Wait, do you have a room right now?
Yeah.
I'm
Okay,
saying
we
no.
still don't have a room in
Yeah.
the water park.
So,
Okay, find a room. You'll get water park passes.
no, she's gonna give us water park passes and we're gonna sleep in the water park.
Yeah.
Hide in like the
Yeah.
We're
the
gonna
towels.
We're gonna play hide and seek against the cars.
Oh, okay.
All right. I don't know. I yeah. If I get it, I don't know if we use it. Okay. Anyway, are you guys still working on these? Yeah.
Yeah. I only got 2. Or 3.
Why? Did you just expect me to go out there and sleep on the floor or something?
Well, I'll sleep on the floor as long as I have a room to sleep in. Yeah. I'll bring sleeping bags.
I feel like that's necessary information to tell someone. If we even have a room the day before.
Bless you.
Well, Garrett, if you guys are telling us we can't, we can go see Master Chef Junior. It's in Oshkosh on Friday.
Well,
So if I don't go to the Bells, I'm going to see that. To see Gordon Ramsay.
alright.
You're a master
I'm
chef
serious.
fan.
I'll show you. No, well, not really. I don't really watch that much. I just think it'd be fun.
Wait, whose room are you staying in?
Huh?
Whose room are you staying in?
Your business.
Cause
Oh,
Jax.
true.
Okay, fine.
Yeah.
And then Jax's parents are coming home. We're staying in.
What's
Jax.
Jack thinking on the street?
No, we're leaving on Saturday.
What's that?
What's
Jackson
that?
is
Well, the basketball team is going, the boys basketball team goes to the Dells for a tournament, so a lot of people are staying in the Dells this weekend.
There's not enough for
And
me.
these guys are trying to get
It's
themselves
all down, there's like,
without
there's
having
three
families.
sections next to each other. So it's 1, 2, 3, and then there's like five in these.
Alright,
There's no way nobody gives us a room.
Yeah.
There's a way that nobody gets your room.
We'll just prepare to sleep on the floor and someone's gonna
Yeah, we'll knock on every single door.
You
If you think anybody's gonna see you sleeping in the hallway, they're gonna think it's cold.
Yeah.
They're gonna be like, how'd you get in? It's like, a key, obviously.
alright guys, so, in number 1, what'd you guys do to multiply that fraction, 4/15 times 9 over 8, what'd you guys do? You can cross cancel, so we don't cross multiply, we cross cancel. So we can divide those each by 3, and this becomes a 3 and this becomes a 5. We can divide these each by 4, this becomes a 1, this becomes a 2. So essentially we can cancel if something's the same on the top and the bottom. Then when we're done, right, did I do that right? I think I'm good. And now when we're done here, we multiply across the top and multiply across the bottom. So 1 times 3 and then 5 times 2. Bad news is multiplying is the easiest one of all of these. So if the other ones were, like that one was bad and you didn't know how to do the other ones, these ones aren't much better. But the big thing is with number 2 is realizing there is kind of just a rule to know, and then it becomes just like number 1. What do you need to know what to do in dividing? Do you know? You might have heard it as like keep, switch, flip. Does that sound familiar at all or something like that? So division of fractions, technically we don't divide fractions, we multiply by the reciprocal. So we keep that first fraction the same, and then you change it to multiplication, but then you flip that second fraction. So that's with division of fractions. We don't technically divide fractions, we change it to multiplication. And you always flip the second fraction. And now it just becomes a problem like over here. So now we can cancel, this becomes a 4, this becomes a 5. We can divide those each by 3. And yeah, your calculator does these for you. I mean, like, you probably use that a lot, like use your calculator a lot with fractions. However, once we throw variables in it, knowing some of these like kind of tricks are important so that we're able to divide our fractions. Now number 3 is just called a complex fraction. It's really just division. So again, it's essentially the same thing that we just did here. However, they're just kind of stacked on top of each other. So we essentially have this problem, and then again we're going to keep, switch, flip. So times, and now again we can cross cancel. Now just so you guys know, you don't have to cross cancel, except cross canceling is helpful because otherwise we have to simplify at the end, and to multiply 16 by 9 is not the easiest thing in the world, or you know, so like we cancel, it makes these numbers a little bit smaller and nicer to work with. Divide those by 2, divide these by 3. And then we're left with 24 over 7. And we're good with improper fractions. We don't want to change that to a mixed number or anything goofy like that. All right. And then, so that's multiply and divide. I think those are easier than addition and subtraction. Addition and subtraction, what do we need to have happen before we can even start the problem? You need the same denominator. So number 4 is actually pretty easy. You have the same denominator already, but in like number 5, we need common denominators. So that's one of the things to be important, like to recall and remember about this. Again, you guys learned this at some point. It's just we kind of have put it on the back burner a little bit. So now we just add the top, and then you just leave the bottom. You don't do anything with the bottom. That's all you have to do in a problem like that. Pretty straightforward. However, where it gets tricky is when they're not the same. So 8 and 6, bless you, aren't the same denominator, so we can't leave them that way. So we're going to switch this over. 8 and 6 can both become 24. Now you could multiply them together and get 48. 24 is a little bit better. It's a little bit smaller of a number. It's nicer to work with. And so that's because it's a multiple of those numbers. And so they can both become 24 by multiplication. This one, if I multiply this by 3, that means I have to multiply the top by 3 as well. And this is a really important step that we're going to need for today. So understanding that whatever I do to the bottom, I have to do the top. And it sounds logical or that you knew how to do that, but once we throw variables in there, that for whatever reason people forget some of those important rules. Here we multiply by 4. Same thing to the top. Then we're going to subtract the top, and then just leave the bottom. And then we can't simplify any further, so that's it. So if those weren't so bad, hopefully today won't be terrible. At the same time, I mean, you guys are good at the other parts that are going to go into this. So we're going to have to do some factoring. We're going to have to do, again, following some of these rules. So we're going to add, subtract, multiply, and divide rational expressions. Now, the good news is we'll do a little bit more of that tomorrow. So just so you guys know, this isn't one day and we're done. We're just going to use it a little bit more tomorrow too. So this, if you look, this is actually a pre-section to 5.1 because technically 5.1 requires that we're comfortable with all this, and I didn't want to jump into that, especially on the first day back, semester. All right, we don't need a break quite yet. No break yet.
It's a fun day.
No, it's not. Get
It's
your
like the first day of school. We have to learn the classroom. All those
Where's
things.
the pencil sharpener? Where do I sign up to go to the bathroom? All those important things. Yeah. All right. Okay. So guys, these first couple are just talking about monomials, so single terms, and talking about multiplying with those and kind of how we cancel and simplify. And then I'm going to talk to you guys a little bit about domain here as well. So we want to multiply these, but we also want to cancel as we're able to. We want to simplify as much as possible. And it says we want positive non-zero exponents. So no negative exponents at all. We want to keep everything positive. So take a minute to see if you guys would figure out how you could cancel some of these and simplify. Give you guys a little bit of time to try it before I start talking. We'll take a break at the halfway point, so halfway down the page, or the end of the page.
You can do it again.
Yeah, we can do it.
Remember, it's a good day.
Here.
But just think, because it feels like a Monday, that tomorrow will be like, what? It's already Friday, right? No.
Yeah, but tomorrow's a half day.
What?
Because we leave for the Dells.
Oh.
You get to leave early even though you're up in a hotel room?
Yeah.
We're not leaving early. We're staying the day.
So we leave early?
Yeah.
Let's go.
I wasn't going to until you told me you wanted.
I'm leaving early.
So
I know. I asked Mr. Donahue, I'm like, we don't get to leave early, do we? He's like, no, they're not really doing anything in the it's not like they're practicing or anything in the Dells.
So
They
basically,
don't even play Friday.
Yeah, they play Saturday. So.
basically I'm missing trade.
Oh, no.
But I don't know.
That's right. You have me twice a day.
I know.
What in the
Aren't you
world?
so excited to see
Yes.
Oh, really?
twice a day?
All right. Somebody else is in trig. You are too. Yes. Just so
Yeah,
you guys
yeah.
know, early on in trig, I really feel like we've already. You guys realize a lot of the stuff in trig overlaps from here, so
Perfect.
you'll be kind of bored.
That's perfect. I'm okay for it.
I was gonna do it, but then I didn't back in communications instead.
I mean, when you take trig next year, though, you'll be like, this is probably
Exactly, take trig next year.
Well, you should have told me that before I decided, because then I probably would have took trig because it's so easy.
Well, because it's a lot of the same stuff as this.
Yeah.
Like,
Well, there's definitely
It's
overlap.
so good.
There's
There's
just so much
overlap.
overlap.
Because there's a lot more signs, so the signs.
Yeah, there's all these identities and properties. Do you love those? Yeah.
How many math credits do you
It's
need?
good.
What?
How many math
Yeah.
credits do you need?
But you don't need
Three.
to take trig. There's
You
no,
need three.
I know a lot of people.
But you have to take stats at some point.
Yeah.
So
that's a half, right?
stats is a half, so then trig is another half.
Well,
I
does,
mean,
if you took algebra in 8th grade, does that count? It counts a half?
I don't think it counts as a high school credit.
It does.
No, it doesn't.
If you took it in 8th grade, she's asking.
No, it counts as a like
Yeah, it's just-
Yeah, I took.
That's
Yeah, it's
Yeah.
not.
Okay.
Is that for the? That's for this school.
Yeah.
Yeah, look at your trend.
Those of you guys watching online, feel free to fast forward through our discussions.
Yeah.
All right. Okay. So in example A here, guys, we can do some cross canceling. So if you guys hopefully notice, like the 16 and 8 can become like a 2 and a 1. And the 3 and 9 can become a 1 and a 3. Now the numbers hopefully make sense to you, that you have 1 times 1 over 2 times 3, which is 6. Now the variables that might take like a little bit of like kind of extra like thinking here, obviously. So we have x, and then x squared on the bottom. What's going to happen there?
They cancel.
Yeah, it's going to cancel because technically this is going to be x squared on top and this is going to be x squared on the bottom. So this just becomes 1/6. If you're able to do that without showing those steps, just if something's the same on the top and bottom, they can cancel. Now B gets a little bit tougher because there's more variables involved, kind of a little bit more. Not everything cancels in this case. So again, we can cross like cancel. So 7 and 49. The 14 and 12 can be divided by 2. Do you see anything else right now?
The x is
So I might clean this up a little bit. Does anyone else see something they really want to cancel right now?
The sevens.
The 7s. I would probably cancel the 7s right away. The z's, yeah. The 7s, I'm going to cancel right away because they're on top of each other. So even up and down works okay. I like kind of regrouping, kind of seeing where we're at here. So I don't know. So I have 1 on top, x squared y, z. We can talk about all those in a second. And on the bottom, I have 6. And then z to the third, x, y to the fourth. Now when I teach this in algebra, I always, and I think algebra 2 as well, I usually say, where are there more variables? How many more are there? Because the 1/6 is going to be obviously actually the same as over here. If I look at the x squared over x, where are there more x's? How many more? 1. So it'll just be an x to the first on top. The y's, there's 1 y on top and y to the fourth on the bottom. So one of these will cancel with one of these, so there's going to be 3 left on the bottom. And then finally the z's, there's z to the first over z to the third. One of these will cancel with one of those, so there'll be z squared on the bottom. Okay. So that's simplified. Now what we're going to talk about next is the domain of a function. So we talked about domain before, but domain is super important with fractions because remember that what's in the denominator, if it's in the denominator, it can't equal 0. So it's the possible x values. And a lot of times, like this book is going to call them restricted values. So what they mean by that is basically what values can't we use? So they might ask it this way. So like for example, if I have 1 over x, I would say x cannot be 0. So that would be how they show it as a restricted value. Basically, x can be anything I want, it just can't be 0. So we're going to use that a lot today because remember the denominator can't equal 0. That's our only restriction on fractions is the denominator can't be 0. The top could be 0, that'd be fine. So we're going to have to kind of look for that as we're going through these. So we'll go through these 2 examples and we'll take a break for Garrett. And the rest of you guys could also break though. All right. Now, one of the things I'm going to tell you guys, a big no-no, and it probably has some sort of like cute puppy meme that goes with it, is you can't just cancel the x's when you see them on top of each other like this. So if you just started doing a whole bunch of canceling, I'll show you guys what we can't do here. So like if you look at that first part of this, I can't say, oh, there's an x on the top and the bottom, so this just equals 3. This is a big no-no, so I'm going to put a big red line through this. So can't do that. The reason we can't is because of the addition and subtraction. You can only cross-cancel like that when it's multiplication and division, so like what we had up here. Down here, we have a whole bunch of addition and subtraction. So what we prefer to do is if we can, some of these, like this problem, I can change that and rewrite it in a different way. So hopefully you guys see something like this and say, oh, I know what to do with that. Like it's not like this is your first time seeing something in this form. So we're able to rewrite this. We're going to factor it. What factoring does is it makes it, changes it from an addition problem to a multiplication problem. So we're going to factor. So x times x, tell you guys most of the time the factoring will be pretty nice factoring, not any of the crazy like x things. I mean, it's not possible. It's possible those come up. But we want to multiply to get 12, but add to get 7. So 4 and 3. All right. Now that I have that, now there's some canceling that can happen. So what do you guys notice that can cancel? Yeah, the x plus 3's will cancel because now it has become multiplication instead of just addition. Anything else you guys see? Yeah, this and this is kind of like a problem we just did up there. There's x to the second on top and just an x on the bottom. Now since that's multiplication, we can cancel there. So there's more x's on the top, there's just going to be 1. And so like this will cancel with that. So all that's left then on the bottom is x plus 4. But we're not quite done with this problem yet, so that's the simplified version. However, it does say we needed to state the domain. So what values of x can we not use in this problem? -4. Because that would make this denominator equal 0. But I wrote a comma. What else are we missing? There's something else. Does anyone else see it?
0
0. Why is 0 in cash? You're right.
times 3.
What's that? Oh, the top can be 0 though. That's okay. But 0 is one of the excluded values. But that's not the reason why.
I don't know why. I just
When we It's okay. When we talk about the domain, we have to look at the original problem, or even the one we rewrote. Why is 0 not work?
Because 0 would be under x.
Yeah, that would be a 0 there. So 0 doesn't work there. And even though we canceled that, it still was part of the original problem. How about, there's one other value. You see it? So we have 0, -4, and -3. So this is also an excluded value we have to include. If you were to graph this original function, those values wouldn't make sense for that graph. So letter B here, lots of factoring and stuff we can do. Again, big no-no, do not see y squared and cancel it. It's gonna be like, I mean, I think I say that 100 times and then I'll still have somebody do that in the test and it's like they forget everything they had ever learned. But so there's a whole bunch of factoring that we're gonna do here. This first part I think is the easy type of factoring. The bottom can be factored. So multiply to -4, add to -3. What do we get? -4 and 1, thank you. In unison. Now y squared minus 25. Do you guys remember how to factor that? Yeah, that's one of those difference of squares. It's going to be y times y gives us y squared, but then we're going to multiply to get -25, but add to get 0. So that middle term will cancel out. So plus 5 minus 5. Those come up a lot in here. And then how about this bottom over here? This one has like 3 different types of factoring in the same problem. What to do with that one? It's probably the first type of factoring you learned was you can just take a y out of these two terms. Now this is a place I would actually stop and look at our domain. Before I even cancel, so I don't forget about it, this is a great spot to look at the domain because everything's nice and factored. So x cannot equal -5, 0, and 4. So I like doing the domain on this step just because it's all like kind of set up nicely for me to like visually see that. Now I'm going to do some canceling, or a lot of canceling. So they're exactly the same. They can cancel. But I think that's all we can cancel in this case. So now don't feel pressure to FOIL. If we know nothing else can cancel, foiling it through is not going to simplify it any further. So just leave it. Throw your pen. Like you just don't care here. All right. So nothing else can, so distributing that in and making that a trinomial, it is not necessary. Okay? All right, why don't we take a little break here.